Hey guys, Mr. Bowman here. Today's learning objective is in blue, and we are learning to use the discriminant to determine how many points of intersections exist. And the key word from this learning objective is the idea of the discriminant, and this is something we looked at in the algebra topic. So just to recap, the quadratic equation can take the form ax squared plus bx plus c. To solve that using the quadratic formula, we did x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that was divided by 2a. And it was this where the discriminant was found, so the portion within the square root sign was the discriminant, and that related to b squared minus 4ac. And we can use this bit of information to figure out how many points of intersections there were. So if our discriminant, so if b squared minus 4ac is above 0, there will be 2 points. If b squared minus 4ac is equal to 0, there will be 1 point. And if our discriminant, b squared minus 4ac, is negative or less than 0, there will be 0 or no points of intersection. So we're going to go through an example of each, and those examples are already on a screen, just to demonstrate how many points of intersections there are and how we can use the discriminant to mathematically justify the number of points that we've figured out. So we're going to start off with our first equation, and we're going to start off with, or we don't need to rearrange because we can see y is already the subject of that. So we're going to substitute that straight in. So x times negative 0.5x plus 5, that comes to 8. So that y has been substituted above. We then look to expand our bracket. So negative 0.5x squared plus 5x minus 8, that is equal to 0. From that, we know that a is equal to negative 1/2. We know that b is equal to 5, and we know that c is equal to negative 8. And we can use that information to find the discriminant. So the discriminant is equal to b squared minus 4ac. And in our case, that is going to be equal to 5 squared minus 4 times negative 1/2 times negative 8. And when we go through and simplify that, so that's going to be 25 minus, so negative 4 times 1/2 is negative 2. So it's going to be, sorry, positive 2. Positive 2 times negative 8. And that's going to be 25 times, so 25 minus 16, because 2 times negative 8 is negative 16. And that there is going to give us a discriminant of 9. So what that means, so therefore, b squared minus 4ac, that there is greater than 0, which suggests we have 2 points of intersection. So that there would be how we mathematically justified it. And if you were curious about that graph, so that graph was a hyperbole, so it kind of looked a bit like this, and it had a straight line that ran through this area, and 1.2 points, those were the 2 points of intersections that we've confirmed. So if you haven't got this example down, please pause the video and please get it down. What I'm going to do is I'm going to clear that last graph. We're going to move on to the third one with a different pen color, so we'll use yellow. So we're going to move on to this third one here. Let's see what that comes out to, and then we'll finish off with our middle set of equations as well. So first step, in this case, we don't have y as the subject of an equation, so we do need to do a bit of rearranging. So this bottom one is going to be y equals 5 minus x. We can then use that y to substitute into our top equation. So x squared plus 5 minus x all squared, that there is equal to 12. So that's going to be x squared plus 5 minus x, 5 minus x, that's equal to 12. X squared plus 25, so that's 5 times 5, minus 5x plus x squared is equal to 12. And then we can look to do our final simplification there. So that's, we've got 2x squareds. So 2x squared minus 10x. And we'll move this 12x to the other side. So we've got 25 from here minus 12x. That's going to be positive 13. And that's going to be equal to 0. From here, we now have our a value. So a is equal to 2, b is equal to negative 10, and c is equal to 13. And we can plug that into our discriminant formula. So b squared minus 4ac, that's going to be equal to negative 10 squared minus 4 times 2 times 13. So that's going to be positive 100 minus 4, minus 8 times 13. And if we do the maths with that, that's going to be 100 minus 104, which is going to be equal to negative 4. So we've got a negative discriminant. And if we have a look back down the bottom right at our combinations, we've got a discriminant that is less than 0, which means we're expecting 0 points of intersections. So let's have a look. So therefore, b squared minus 4ac, that there is less than 0, which means there will be no points of interception. Awesome. So that was our last one. And if you were wondering about that graph, I'm just going to draw it. So that graph was actually a circle, and it did have a straight line that narrowly missed, or do a better one, that narrowly missed the circle. So that means there were no points of intersections, and that was confirmed by our working in our discriminant of negative 4. So hopefully this is making sense. If you haven't got this one down, please pause the video, get it down. What I'm going to be doing is I'm going to pause the video, clear our working so we can finish with our middle one, and then we'll wrap up. Okay, we're on to our final one. So we won't be shocked to hear, but the only one we haven't looked at is when there's 1 point of intersection. But just to recap, this first graph was a hyperbole with 2 points of intersection. This last graph was a circle with, I wrote 1, but with 0 points of intersection. And this one here, there is going to be 1 point, but let's show how that works. So our first step, again, we don't have y by itself. So we are going to need to do a bit of rearranging here. So I'm going to look at the bottom one. So y is going to be equal to 3x minus 9. I'm then going to substitute that into the top equation. So I'm going to substitute the y up here. So that's going to be 3x minus 9 divided by x. Well, that's going to be equal to x minus 3. I'm then going to take this x to the other side as multiplication. So 3x minus 9 is equal to x times x minus 3. So 3x minus 9, that's going to be, if we expand that, x squared minus 3x. And from here, we can look to simplify. So let's move everything on this side to the other side. So that positive 3x becomes minus 3x. So we've got x squared minus 3x minus another 3x plus 9, which is the opposite of that minus 9. So that means 0 is going to be equal to x squared minus 6x plus 9. From here, we do have our a, b, and c values. So a is equal to 1, b is equal to negative 6, and c is equal to 9. And we can use those and plug them into our discriminant formula. So b squared minus 4ac, that's going to be equal to negative 6 squared minus 4 times 1 times 9. So that's going to be 36 minus 36, which is going to be 0. And that confirms our view. We're expecting 1 point of interception, and our discriminant is equal to 0. So therefore, b squared minus 4ac, that is equal to 0. That's a bad equal sign. I'm going to do that again. That's equal to 0, which means we would expect 1 point of interception. Awesome. So well done if you got that. And if you were wondering how that one looked, that one there was actually a parabola with a tangent going across, and it just left that 1 point of interception on the side. So guys, hopefully you found this video useful. What we did down the bottom left, we learnt how to use the discriminant to prove how many points of interception there are on a given graph. If you haven't already, please make sure you get down each of the 3 examples with my rough drawings. Now let's get into heaps and heaps of practice.